Hi, this is just a quick show and tell video on some vintage test equipment I bought off of eBay. A few weeks back I saw on Mr. Carlson's lab channel he was demonstrating the Philbrick K2 operational amplifier. Due to my interest in op amps, I took a look on eBay and actually found a few of these units. I ordered those, but originally actually received the K2-P chopper stabilizer. The seller was not aware there was a difference, but I was able to purchase the K2XAs to pair with the K2Ps, and the seller threw in another K2P that was missing a tube. My plan is to build a chassis to experiment with these op amps in a basic analog computer configuration, but first I need a way to provide power to the op amps. Unlike modern op amps, the K2 requires plus and minus 300 volts at about 15 milliamps per op amp, along with the 6.3 volts AC filament voltage. Mr. Carlson improvised an unregulated power supply in his demonstration, but he has much more experience, knowledge, and resources than I do. My first thought was to try to copy the power supply from the Heathkit EC1 as a make-do effort, but I searched eBay and found this Philbrick R-100B power supply, which was originally sold for exactly this purpose. The unit I found was missing all its tubes and was pricier than what I would have liked, but it also came with an assortment of K2 bases, and it was the only unit available. The R100B provides plus and minus 300 volts at 100 milliamps current, so it has plenty of power for the 2 or 3 op amps I'm planning for. It also has a direct line connection for powering a filament transformer. Note that this means the output connector has several potentially lethal voltages. Even the monitor terminals on the front panel could be dangerous. Here I've got meters monitoring from left to right the input voltage, which is about 111, the input current, which is 504 milliamps, and the minus output voltage at 300.0, and the positive output voltage, which is also 300.0. The unit's been very stable, but I'm noticing a little bit of instability, and the positive output voltage pot is to the end of travel, so there may be some issues to resolve. I'm not sure if it's the tubes I installed or possibly resistors degrading over the years. Now we'll focus on the front panel and just the output voltages. Since this power supply is designed for industrial use, basically in an analog computer rack, its front panel is fairly minimalistic. From left to right, we've got the power on switch and power on indicator. Next is the monitor outputs. It's interesting, in modern power supplies you typically have a low voltage reference for your outputs, but here the monitor voltage is the actual output voltage. So this is, effectively a lethal voltage right here at plus and minus 300 volts, with also a chassis ground connection that are actually capable of 100 milliamps on each output. So be wary. Definitely wouldn't recommend working around one of these if you're not familiar with high voltage. Next we have the input line fuse. That fuse is a 5 amp fuse, but it's actually set to provide current to both the power supply itself and the output connector, which could be used for powering filaments in the operational amplifiers of the analog computer itself. There are also individual circuit breakers for each output, and those are set to trip somewhere above the 100 milliamp rated output. Next are the adjustments. There are an adjustment screw for each individual output. Actually, I should say an adjustment potentiometer. The minus adjustment will provide, I believe it was plus or minus 8 volts on the negative output, and then the positive output should give you I believe it was plus or minus 1.6 volts, so it's narrower because it just has to track the minus output. And we'll get into that a little bit when we talk about the schematic. Next we have the output switch and the output indicator. Right now I've got the output off. The actual connector for this unit was damaged. I believe that was damaged prior to shipping when it was shipped to me, but it was damaged beyond repair, so I just had to tear that off. And I was thinking that might as well have happened because I don't think it was possible. It was a really obscure connector, so I don't think I would have been able to find a connector to mate to it, and I'll probably end up just putting a terminal block on the output cable. So right now I'm only monitoring this, of course, with no load and through the output front panel monitor connectors. We can see right now the output has actually drifted a little bit even since the video started. That's a little bit of an annoyance, but actually it gives me an opportunity to demonstrate adjusting the front panel adjustment. So the negative side is actually right on at 300 volts. We'll go ahead and adjust the positive side, and sorry my eyes aren't that good, so I'll have to kind of get in here and find the pot, and as I recall it's counterclockwise. We'll bring that up, yeah. And that's interesting because that did actually bring it off of the limit. So now that it's run for a while, maybe it's actually stabilizing a little bit better in a better operating condition. It's interesting about this power supply. I believe in the manual they say, you don't want to adjust it until it's run for well over an hour, and I've had it on for that amount of time this morning. But they also say it will become more stable after the first 100 hours of operation. So it's got a fairly long burn-in period. That's probably the tubes burning in and kind of reaching their stable operating point. So that's it for the front panel, and now that we've got it adjusted, I guess I'll go ahead and turn it off so we can take a closer look. But before I do that, I'll go ahead and get a quick video of the tubes just so you can see those lit up in the back there. So there's a quick look at the tube complement in the back. I'm not sure if the the tubes are on, but you'll only see the filament, if at all, in the main regulator tube. That's the one on the right, and possibly in the gas discharge regulator tube, kind of nestled in there in the middle. That's hard to see on the back of the camera what the video will end up looking like, but I thought I'd give a quick shot of those while the thing is live. So I'll power it down and then we can turn it around and take a look at the rear panel. Now on the rear panel, from left to right, first we have the tube complement, which you just saw earlier from the top view. The large tube on the left is V11, which is the series pass regulator, which will be controlled by the air amplifier. That's a dual triode, so there's one half of the tube is dedicated to each of the respective outputs. That was not available as a new tube, but I found new old stock for that, and actually that was one I had a little trouble with. The first tube I tried was dead and had no regulation, but I ordered two in the first order, so I was able to swap the tube out and get the unit to regulate, and the eBay seller of that tube was good to send me a replacement, even though it was effectively sold as is. The next tube that I'll talk about is a small tube kind of in the center of the cluster, and that is a V134, which is an 85A2 gas discharge tube. If I recall from the manual, that runs at about 85, or it might have been 83 volts. So that's used as a reference, and it appears kind of like a Zener diode to compare the feedback voltage from the minus supply so that it can regulate the minus supply directly to that stable voltage on the gas discharge tube. That was another tube I purchased as a new old stock, and it worked fine. I bought a couple of those, but I haven't tried swapping in the second one yet. Then we've got a total of 6. Those are 9-pin tubes, and those are all dual triodes. On the top are V101, V102, and V103, which all 6 together form a high gain air amplifier for the positive output. And then the 3 tubes below are V131, V132, and V133, which are the high gain amplifier for the negative output, and that's the one that is the key reference to the gas discharge tube. For all 6 of those, I ordered new JJ tubes. It's kind of interesting. The V101 and V131, which are effectively the differential amplifier of the air amplifier, are 12 AU7s. The next tube in the chain, V102 and V132, are 12 AX7s. And then V103, V133 are 7025s, which most people these days say are equivalent to the 12AX7. So I ended up buying 4 12AX7s and just 2 12AU7s, and used the 12AX7s where the original schematic calls for a 7025. I think that's interesting because it seems like back in the day, Philbrick, if those were in fact identical, would have just used 4 12AX7s. So it's something tells me there was a reason for using the 7025s, but maybe it's not important in most applications. Next are the electrolytic caps, and to be honest, I haven't identified those. I haven't really looked at those closely. I'm running this through a dim bulb tester right now, so just in case there's any issue with those. So I haven't yet leak tested them. I'm hoping I can get away without having to recap this, but I will eventually leak test those. Philbrick designed those with about, from what I can tell just as a quick glance at the schematic, they're rated at about twice the voltage that they see in operation. So even if they leak at their normal rated output voltage, they may be okay to use, but that's a little risky, as Mr. Carlson always says. Between the caps and the transformer are the line in at the bottom, and then the actual output cable. I actually put the output connector on above the caps on the case, so you could just see how mangled that was when I received it. And it looks like that's just something that happened over the years. Again, I would have had to replace that connector anyway, but I'll go ahead and pull up the output connector so you can see that. I've just got those with heat shrink over them now. I haven't even stripped them back yet, but just to be on the safe side, I wanted to make sure they didn't short out to anything. There are 3 connections for the output voltages, the minus 300, plus 300, and return. And then the other 2 connectors are actually the line voltage that could go off and power the filaments of your operational amplifiers. So I've got a filament transformer that I purchased for that I'll put in the chassis with the op amps when I get to building that. And then the last item, of course, is the input transformer. I think I was real lucky with that. It looks in perfect shape. I haven't seen any signs of rust or anything in the lamination, so it looks like this was well cared for. I can't say how many hours are on it, but it's definitely in great shape, so I think it should work well. And I might have to look carefully at the resistor values to make sure all the resistors have held their value. So next we'll pop the top on it and take a look inside. I think you'll like the look of that. I'll need to do this in 2 shots, but here you can see the first half of it. Basically, right behind the transformer is a nice circuit card with the bridge rectifiers and I believe those are bleeder resistors across the rectifier there, or load resistors, you might look at that as. And then I'm not going to get into much detail at this level. You can see it's a pretty tightly packaged unit, but it's all professionally done, so really nice quality on that. Looks like this is kind of a precursor to a printed circuit board. It's actually just a circuit card with terminal blocks and then point-to-point wiring, but it's really neat and looks like it's untouched. That's one of the reasons I'm a little hesitant to get in there. Hate to disturb the professional quality assembly there. And then it's interesting, there's a really large, I'm going to have to check the schematic to see, don't recognize what power rating that is right off top, but it looks like at least a 5-watt carbon comp resistor. And then the wiring for the filter capacitors there is really tight, but it looks like it's well done. All the wiring is twisted as it routes from place to place. And then there is a heavily insulated cable with the output. That's this cable here. That's for the output, going to the output connector there. I won't go into the stuff on the front panel. There's not much to see about that. There's just, you know, the indicator and then the top circuit breaker there over on the output there. So that's about it for this shot. I'll go ahead and move it over so you can try to get a better shot of the circuit cards over on the actual air amplifier section of this. It's a little tricky to get this lit well, but I just wanted to show briefly some of the circuitry around the air amplifier. Again, these are sort of point-to-point wiring boards, but with a little more sophisticated than just what you might see in a typical amplifier. There's another one of those high-power carbon comp resistors over across the regulator tube. That'll be interesting to see what that is on the schematic. And you can see a couple of the nice, I believe those are poly caps, the yellow caps there, so those are generally pretty high quality caps. So that's about all I wanted to show for the unit itself. We'll go over to the computer and take a look at the operating and service manual, take a look at the schematic, and discuss a little bit of the circuitry there. This is the philbrickarchive.org website. It's got a lot of information on the George A. Philbrick Researches company, as well as information on analog computers and early operational amplifiers. So there's a lot of good information on this site, but it's not as well organized as I might like. The easiest way I've found to find anything is just search for it on the page. So I'll Control F, and then I think I've already got the search for R-100 in there. Go ahead and return. And that's the first instance, but that's not actually what I'm looking for. I'm looking for the manual. So I'll go a few more pages down, and actually, here we're now in the power supply section, and this is the link to the manual for that. I've already had that open at one point, but this is a really good manual. Another drawback to this is, unfortunately, it's not in PDF format. It's just in HTML, so it's a little harder to navigate than the PDF would be. This is a really good manual. There's a lot of information, and he goes through the theory of ops. He doesn't explain every little circuit necessarily, but most of the information you would need to understand it, especially to troubleshoot it, would be included here. There's specifications, sort of general philosophy. I guess that's almost an overview of theory of operation. Then here, of course, is the meat of it. We'll get back to this later. The schematic. This is sort of the schematic of the series regulator, where the individual air amplifiers are shown just as op-amp or amplifier blocks. And then this is the actual, each individual regulator. I believe that's the the positive output there, and then the negative output there. And we'll kind of peruse the whole manual, and then we'll come back to the schematic for a little more detailed look. And here's an overall block diagram that's convenient. And we get into a discussion of the circuitry here in a lot more detail. Then here is the more detailed theory of ops, I guess. So it gets into component by component there. And this is a little interesting. I've read a little bit on there that this was updated with this page 5. Apparently that was missing from the original file that they scanned. So this was scanned in maybe at a different size there. But the good thing there is the information that you're after is all there. So we won't go through this, page by page, but it is interesting. They also have a maintenance or operation guide. The operation, of course, is fairly simple, but then there's troubleshooting and preventive maintenance, and at the end there's actually voltage and resistance chart for troubleshooting. So I'll probably go through this in detail later to see if any of those old carbon comp resistors have changed value. I think to go through the schematic, I've saved off some screenshots of that. That'll make it a little easier to go through that one by one. So I'll switch to that and we can take a look at that in detail. So here's a good block diagram of the entire circuit. They don't show much detail here, of course, so it appears the 115 is just going straight in, but basically there's a rectifier for each side, and again that large tube was the series regulating element, and then that's controlled by this error amplifier, which consists of the 3 tubes there. Down here the negative supply is showing that it's referencing the gas discharge tube. And then there's a feedback voltage divider for each side. The positive supply is referencing the minus 300 volt supply. So that's just balanced there to provide a 0 volt. And then the other side of the differential amplifier is just looking at 0 volts at the return or common. That way, if that's what allows the positive power supply to track the negative supply. And then they show the load here, but of course that's switched through the front panel switch for the output switch. So we'll take a closer look at that on the schematics. So here's the overall schematic, and as I mentioned earlier, the actual error amplifier circuits are just shown as amplifier blocks in this for simplicity. But this gives a lot more detail. I won't really delve into this in detail. If you're if you're interested in that, you could definitely look at the manual. It's all spelled out there in detail. But basically, you've got the line switch here, and again the 5 amp fuse on the front panel. Then notice these pins are the ones I was referring to. They go over to this output connector, and you would run those through a filament transformer in your analog computer to provide the filament voltage for the individual op amps in the computer. And then there's just a neon bulb, if I am looking at that correctly, for the front panel power on indicator. Then the main power transformer, there are 2 rectifiers, one for each side, of course. And then I haven't looked at this in detail, but it looks like there are separate filament outputs there. Then I believe, these are the circuit breakers on the front panel there, and then this is the large series pass regulator. So as the error amplifier will drive the grid of that tube to maintain the stable output voltage, and I won't go into any more detail than that. It's all covered well in the theory of operation section there. They do show the front panel adjustments there, so these are to adjust out any variation in the circuitry with the circuit resistance values. Keep in mind in those days the resistance values were generally 5 or 10%, so you had to have some pretty substantial trim there. And then there, all the electrolytic capacitors, it's filtered pretty much throughout, and then the filtering, for the output stage over here. Then this is that front panel switch that I have so far just left in the off position, and I think that's safe. There's really not much beyond that for the output connector. And then this is a connector that was broken that I had to remove. So it's got the 3 connections for the output voltage, and then again these other 2 connectors for the line voltage, which will have to be stepped down to the 6.3 for the filament. And there's also the front panel output on indicator. I haven't really checked to see if that works yet, but I assume it would, since those are usually long-lasting parts there. So that's basically it. I know that was a really rough explanation of the circuitry, but I didn't want to, it's, explained far better than I could in the manual itself, and you'll know where to find that. So next we'll take a look at the actual circuitry that's inside these amplifier symbols here. So this is effectively the air amplifier. This schematic is a little bit busy, but as you can see, it's almost 2 identical circuits. There are some subtle differences that I'll get into, but we can take a look at them one at a time. The bottom part of the schematic is the negative output, and you can tell that by the gas discharge tube here as the reference, and then the top section is the positive output, which uses the negative output as its reference. So I'll zoom up a little bit if I can on the negative output section. I'll describe this to some degree, but I won't get into great detail because it's explained a lot better than I could in the manual. Basically, this is the gas discharge tube. It behaves similarly to a Zener diode and provides a reference voltage at this grid of this triode. You could look at this triode, it's a differential amplifier, so it's going to amplify the difference between what's on this grid and what's on this grid. On this grid we have effectively the feedback voltage, so we've got common here through this voltage divider, which includes the front panel pot, and then this resistor down here to the actual output there. So this is a little different than what I'm used to looking at, but you could, if you look at a normal power supply, this would be the feedback section, with this being the feedback voltage. That voltage is effectively going to the negative input of this differential amplifier, and then this would be the positive input of the differential amplifier. And I think the easiest way to take a quick look at how that works is to take a look at that in Spice. So we'll break away from this circuit right now and look at that in Ltspice. So here I've reconstructed the feedback and reference circuits in Ltspice. If you may need to go back and forth a little bit between this image and the actual schematic to make sense of this, but that's basically what it is, and I don't want to spend a lot of time in the video going over that. But I basically pulled these values for these resistors out of the schematic, and these 2 resistors are effectively the front panel pot split in 2, so it's as if the pot is set directly to the center of its travel there. And then instead of drawing in a Zener, I just drew in a voltage source wired at the right polarity with the current limiting resistor for the gas discharge tube. So this V2 effectively represents an 85 volt gas discharge tube, and this would represent the output voltage. So if the output voltage is at minus 300, this voltage divider sets the feedback voltage, and then the gas discharge tube and R6, which are effectively another voltage divider, provide the stable reference that that's compared to. And I just have this set up to look at the DC operating point. So when I run this simulation here, we can see the reference voltage is minus 215 and the feedback voltage is minus 215.746. So of course that would be taken out by the adjustment of the pot to match the 2 voltages. And that is effectively the situation where the air amplifier would be satisfied, I guess is the way I would put it. And effectively what happens is the air amplifier drives the series regulator to achieve this balance so that the feedback voltage equals the reference voltage. So I thought that was worth taking a quick look at, just to understand that, yeah, the circuit values make sense for the regulation there. So with that, we'll go back to the schematic. So here we are back at the schematic, and as I've explained the operation of this differential amplifier, you can see the rest of the circuit is really just a DC coupled amplifier. So there are 4 more stages of amplification, which I won't go into any real detail on, but effectively this just provides an overall error amplifier with a gain. In the text it describes it as a gain on the order of 1 million. So it's a very high gain error amplifier, and the high gain, of course, will minimize the error in the actual voltage. So ideally it would be on the order of 1 part in a million of error there. I'm not getting results that good right now, of course, but that may be some issues with the circuit there. And then I'll take a quick look. The positive version, unsurprisingly, is nearly identical, but the difference here is the reference, or the feedback voltage, is actually compared, as I mentioned, to the minus 300 volt point down here. So as you can see, the top and bottom resistors of this divider network are the same value. So these are it's interesting, they refer to them as 1/3 meg. You don't see that value on schematics very much. I guess that's probably a 330K. And then again, you split the 500K front panel potentiometer. So this signal should be 0 volts when this is tracking properly. You'd have plus 300 down here and minus 300 down here. So you would get the 0 volts down here. So the other side of the error amplifier is then tied to the common point, or the 0 point of the circuit there. And then it's the same configuration. We just have a DC coupled amplifier through the remaining triodes there to boost the error amplifier gain and really amplify the error signal to get a nice stable control value for the series pass regulator. And again, that might not be a very satisfying explanation of it, but if you read through the theory of operation in the manual there, you'll get a much better idea of how the circuit works there. I still need to study up on this a little bit. I may go in there and measure some voltages as the circuit's operating to get a better feel for how the circuit works at a later date. So I think that wraps it up for the most part for this video, but I would like to discuss it while we're on the subject of Philbrick, some of the literature I've come across over the years. So I'll do a quick review of some of the Philbrick literature that I've collected over the past several years. This gem is a recent addition. I just got this, I actually received it last week. Not exactly sure how to pronounce that first word, but it's a palimpsest on the electronic analog art, published or printed in 1960. This is a really interesting, I would call it a compendium of a lot of the literature. Basically, I think the earliest paper is from 1947 and through the 50s on generally analog computers and the development of operational amplifiers. I believe one of the papers in there is literally the first paper from 1947 that actually used the term operational amplifier, and that goes back to the origins of performing the operations in an analog computer. And the subtext there on this cover will give you an idea. This is kind of interesting language Philbrick used in some of these publications they put together. But this is a really interesting. It's about 200 pages, and it's just a collection of papers. It was mostly, even in the papers, they're referencing historical stuff that was developed during and even prior to World War II. So it's a really interesting book there. I'm reading through that right now. This next one is actually really interesting for the, especially the K2, of course. This is the application manual for what he refers to as the octal plug-in computing amplifiers, which is interesting, you know, the term we'd use now. In fact, they're sold as operational amplifiers, but they were generally used in the beginning for analog computers, so they're also generally considered computing amplifiers. And this is, you know, as is typical with modern application manuals, you'll have basic configurations as well as some application circuits to perform a lot of the various amplifier applications or computing applications that you'd like to do. And it also covers basically the K2W, the K2XA, and the K2P. The P is a separate module that I've mentioned earlier that is basically a chopper stabilizer that's used in conjunction with the K2XA in order to really give it an extremely stable output, and that was you know, required for these complex analog computer applications. This next manual is really interesting. It's actually interesting application manuals for computing amplifiers again. This was in the early days of the solid state amplifiers, which were actually hybrid transistor amplifiers like the Philbrick P2. But it is a very interesting resource if you're interested in op amps. It has a lot of information in the front that just covers the fundamentals of operational amplifiers. And it was interesting to me when I first started reading it, in that when you read a modern textbook on operational amplifiers, it almost sounds like they were a recent invention. But this, you know, goes all the way back to the 60s, and most of the fundamental circuits in operational amplifiers were existing in these hybrid amplifiers from the very beginning. So I always thought that was an interesting fact that you don't necessarily get from reading the modern textbooks on operational amplifiers. And you know, it's also written in some fairly interesting language. This manual is actually available completely in PDF form on the Analog Devices website. I'll see if I can find the link and stick it in the description for the video. But that, you know, it's relatively easy to find on Analog Devices website. And I think you can download it either in sections or as one PDF for the whole manual. Now the next manual is really just a later edition of this, but it's kind of interesting to note. One, this is the Teledyne Philbrick company, so it's actually after the, you know, original Philbrick, and you know, through the corporate growth things changed, and then you know, so I'm not sure exactly how that progressed, but basically Teledyne, or Philbrick, became part of Teledyne. And then the other interesting thing on this particular manual is, notice that now it says application manuals for operational amplifiers versus computing amplifiers in the earlier. So now we're more towards, we're sort of leaving the analog computer days behind, unfortunately, and going to where these are mostly used as operational amplifiers in normal circuits. So that's kind of an interesting part of the transitions there. So I think that's all the literature. I've also got a lot of data sheets, but those are, you know, not, you know, pertinent to this particular discussion, so I'll leave those maybe for a later time. Well, I hope you've enjoyed this look at the Philbrick R-100B. Still got quite a bit of work to do with the power supply. I first of all need to test the caps and hopefully not have to recap them, but I'll recap the thing if necessary. And then I plan to test the load reg. I haven't really looked at that, and I didn't think to demonstrate it during this video. The line reg is really good. You know, it maintains the voltage all the way down to 85 volts on the input, and as far as I can crank it up on the Variac, which is, you know, 115, 120. So the output is rock steady through that range of input, so I expect it to be fairly steady. And then I'll probably also put scopes on it and look at step response and look at the error between the two and drift over time. That'll be interesting. And then I'll also go through those resistor voltage tables in the back to see how the resistors are, how stable they've held their values over the years. And then the big thing going forward, I need to build a chassis for the op amps, and I've got a filament transformer, but that's really all I've got right now, so that'll actually take a lot of planning. I gotta be sure I put in the right circuit protection, and it should be a relatively simple circuit, but you've got to have tubes for all the op amps. What my goal is to have a test bed where I will have three locations for 3 op amps, as well as the accompanying chopper stabilizer amplifiers, with the probably use 5-way binding posts for the inputs and outputs, so I can quickly and easily do some testing on these amplifiers. I'll probably do some videos going forward to keep you posted on the progress. Well, thank you for watching, and a special thank you to my subscribers.